Okay guys, today we're going to talk about 9-6, which is graphing polar equations. So we've already talked about how we get them, what they mean, how to convert them back between rectangular and polar. We talked about the new graph, how it's circular. Your center is your pole or your origin. The line straight coming out is your axis. Your angles go counterclockwise. They could be radians or degrees. And also what to do if you have a negative r. You add 180 to the angle or you do the opposite angle. So let's talk about graphing. We're going to start with the basics, just r equals constant or theta equals constant. If it's r equals equation, it's going to be the circle because the whole circle is your radius, right? Your whole circle around. So if I look at A here, it says r equals 3. So everywhere that's 3, so 1, 2, 3, we're going to go around in a circle. So any point on this circle is going to be r equals 3. It doesn't matter what your angle is as long as r is 3. That is the graph of r equals. R equals is the full circle around. If we look at B, that's theta. Theta equals constant is a line. So we look at 210 degrees. We're going to do 210 to the center, and we're going to continue going all the way across, which will be here for the 30. So it's that full straight line across. That's going to be your theta. We can do C and D. C is r equals 4. R equals is again a circle. So we would count 4. So 1, 2, 3, 4. I'm going to go all the way around. And if you haven't figured it out yet, I'm color coordinating the highlighted color with the graph. So the yellow was A, the green is B, blue is C, and the pink is going to be D. So again, C was that full circle around r equals 4, meaning anywhere on that point r is going to equal 4. Last one, D equals negative pi over 3. It's kind of hard to see, but this is negative pi over 3. So negative pi over 3 is 300 degrees. And we're going to do that to the center, and we're going to continue it all the way out. So r equals constant, circle all the way around. Theta equals constant, line all the way across. So now let's have you try this first example. Pause the video, graph it, and then check back in once you're done to see if you were right. I'm going to continue with this. So if we're looking at A, r equals 2.5. So 2.5 is halfway between 2 and 3. So it's somewhere in the middle here. And it's a circle. B or F, theta equals negative 600 degrees. So negative 600 degrees is going to be positive 120 degrees. And theta is a line, so it's going to come out, keep going straight all the way through. Look at G, r equals 6 in blue. That doesn't matter if it's negative because r is never negative. So we count out 1, 2, 3, 4, 5, 6. And that's 6. That's actually 7. This one is 6. The negative r, that will only change your angle, right? Your radius isn't negative. It goes out in all directions the same amount. So it doesn't matter if your r equals a positive constant or a negative constant. It's still a full circle around whatever that number is. And lastly, we have the pink, and the pink one says negative 19 or positive 19 pi over 12. And again, if you can't see that, that's 19 pi over 12, which is 285 degrees. And theta equals constant, or theta equals constant is a line. So we have our lines here. So hopefully your answers match this. And we're going to move on to a little bit more complicated stuff. So to graph polar equations by hand, you want to make a table. So we're going to use 30 degrees, 45 degrees, 60 degrees, and 90 degrees because you can use your special right triangles for those and your unit circle and find all of those values without a calculator. If you needed to, you can use a calculator, but if you did not have one, you could still do this. So for example, we are doing r equals 4 sine theta. So we would start with 0. So I would say 4 sine of 0. Well, sine of 0 is 0, and then 4 times 0 equals 0, which is how I got my r value. Theta is pi over 6. So that's 4 sine pi over 6. And if you don't know off the top of your head what pi over 6 is, we can make a triangle. We can graph it. Pi over 6 is a 30 degrees. Across from 30 is 1/2. And across from the 60 would be root 3 over 2. Sine is y, so that's 1/2. So this is going to be 4 times 1/2, which equals 2. If we looked at pi over 4, that's a 45-degree angle. And both sides are root 2 over 2. Again, sine is y, so we'd say 4 times the sine of root 2 over 2, of pi over 4. And the sine of pi over 4 is root 2 over 2. And that becomes 2 times root 2 because we can cross reduce these. And we can continue so on and so on and so on. If we did one more, 4 times sine of, let's do pi over 2. Because sine of pi over 2 is 1, so that's 4 times 1, which is 4. So we could do this for all 4 quadrants, being careful of positive and negatives. And we get this big chart. So I filled it out here, and this is how I got all of these. I individually plugged in each theta into the equation of 4 sine theta. And then we can graph it. So when when I like to do theta first. So when theta is 0, r is 0. R is 0 right in the center. When theta is pi over 6, r is 2. So pi over 6, we get 2. Okay, next, when theta is pi over 4, r is 2 root 2, and that's 2.8. So that's almost 3. Just put it right there. When the theta is pi over 3, r is 2 root 3, which is 3.5. Let's throw that there. And then we'll skip over the 12, pi over 12s, and go straight to pi over 2, which r is 4. And you'll notice we're going to go back down the same amount. At 2 pi over 3, we get 2 root 3. At 3 pi over 4, r is 2 root 2, which is almost 3. It's at 2.8. At 5 pi over 6, we have 2. And at pi, we have 0. If we did 7 pi over 6, r is negative 2 root 2. So negative We go back, follow it all the way, and we already have that point. At 5 pi over 4, r is negative 2 root 2, so we'd have to go back, and we have that point here. At 4 pi over 3, r is negative 2 root 3. And as we go back, we are going to get that right here. And as r is r is 3 pi over 2, we get, when theta is 3 pi over 2, r is negative 4. So we got to go back because the r's are all negative. And there should be a negative sign in here. I apologize for the 4 pi over 3. That is a negative. So you'll notice in quadrant 3, because all the r's are, if you think of these in quadrants, are over here between pi and 3 pi over 2, I should say. All our r's are negative, so we have to go back here, and they're all here. Same thing's going to happen between 3 pi over 2 and 0. At 5 pi over 3, r is negative 2 root 3, so we got to go back and do the 2 root 3, which is already there. At 7 pi over 4, r is negative 2 root 2. Going back, our point's already there. At 11 pi over 6, r is negative 2. We got to go work back. There it is. And at 2 pi, r is 0. We already have that. So now our last step, and I'm going to switch colors, is we can connect all these points together. And it's not super apparent from my graph because, as you all know, I am not the best at making very, very nice graphs. But essentially, this is a circle. All your points are equidistant away. So you want to be careful because your points can repeat because r is never really negative. When you get that negative value for r, we have to add 180 or go to the opposite angle. So you want to be careful of that. And I'm going to stop this video right here, and you can go ahead and watch the second part to continue.